So thank you for the introduction, Thomas, and hello and welcome to this talk. I want to show you in this talk a new agent-based approach on how to monitor and instrument your Java application without changing your code. But before I start, just a few words about myself. So let's see how this works. I will just use my keyboard, which also doesn't work. No. So let's try it again. Now it works. Great. So just a few words about myself. Hi, I'm Tobi, and I'm working as a consulting at Novatec, and I'm supporting several customers in doing APM and improving their observability. I'm an open source lover, especially open source APM lover. I like the community, and I'm really curious about new tools which are in this area. And yeah, I hope you enjoyed the presentation, and don't hesitate to give me feedback or raise any questions. So first of all, I've brought you this picture, a telephone pole. Because why did I bring this picture to you? Because I found it somehow fascinating how all those different wires are chaotically connected together, but all are part of a bigger system, and they somehow work. And this, in my opinion, really presents the current landscape of open source APM solutions, and the growing complexity on how to put all those tools together is really interesting. And since there are so many possibilities of interoperability, it can quickly get a mess. So we, as Novatec, as our company, we try to order the zoo of different tools by providing a simple website showing the current landscape. It is called OpenAPM. So just out of curiosity, who has ever heard from openapm.io? Oh, cool, a few ones. So those who do not know this page, I will just give you a short overview about the page. Maybe you can also do this afterwards in the demo. I just tell it to you. So this is basically a page where you can also just go to this page where you can have the insight on not all, but most of the existing APM tools, and you just can put them together and see which tools are compatible to work together and which don't work together. So this is a quite opportunity if we want to just have an overview about all existing tools. And I would also appreciate if you have a new tool, but you do not find it on this webpage, just add it. So you can just simply do a pull request on our existing landscape model, and then we can simply add this tool. So to be honest, we are not only observers of the OpenAPM landscape. We are also part of it, because since over 10 years now, we are developing Inspected. And Inspected is an open source application performance managed tool, also an agent-based tool. And so we felt the new vibes and movements in the community ourselves since we developed it for so long time. And let me quickly take you on our journey of our last 10 years. So the whole story started back then in 2005. So the Novatec started there to develop NovaSpy. But NovaSpy back then wasn't really an application performance managed tool. It was more alternative to Profiler, so also an agent-based solution, but more or less for developers to just identify performance issues during the development process. Then in 2008, there was the first version of Inspected, and the purpose and the scope somehow changed a bit, so it became more and more APM tool, which you can also use during the runtime and so on. Then in 2010, there was the first really release of Inspected with a great functionality back then. And back then it still was just freeware, so it was closed source, but it was free to use. And we just used it for our customers to have just a free tool which you can just use. So compared to some commercial tools back then, it wasn't maybe that that good, so let's say, but it was sufficient for most of the use cases. And in 2015, Inspected goes open source. So we realized that it's very important to also have a community, which is part of the idea which we have. So that's why we open sourced it. And then, 2018, we stopped the project. We stopped it. Why? In order to answer this question properly, let me quickly give you an overview about the old Inspected and the functionalities. So just that you get a grasp how the old Inspected was in its concept. So first, we have the agent. And the agent consists of multiple different features. So there was dynamic instrumentation, so you could just change the instrumentation during runtime, which is very cool. And for sure, we supported tracing, also some JVM metrics, which you all probably might know, so CPU utilization and also the states of the different heaps. In addition to that, we had a central management repository, which can be compared to some Zipkin collectors and so on. So it's some component which is responsible for the agent management, for the aggregation, for storaging, and also for traces, API, and so on. And for sure, alerting is also a big issue in application performance management. So you are also capable of doing alerting. And last but not least, we had a rich client, which is really cool, rich client. There you could just configure the central management repository. You could do some analysis, and for sure there was also visualization. And then we realized, okay, there are some core features missing compared to other open source tools. So we added additional ones. So we added an EUM agent, we added a .NET agent, we added an Android agent, an iOS agent, and for sure we also supported OpenTracing. So I hope that the people back in the room can also see this. And in addition to that, we also collected data in the InfluxDB in order to support the visualization in Grafana, because the Grafana visualization is much prettier, much more dynamic than in this old Inspected rich client. So although we tried to go with the trends, we quickly faced some challenges. So there were flaws which are filled with the already existing tool, which really tended us to stop the project. So why investing time in a solution which is always some steps behind already existing open source tools? And it's simply too much effort to invest in all of those different components. And we just had a few persons which worked on this project. So the biggest, in my point of view, the biggest disadvantage of this approach was that we didn't have any open standards. So it wasn't possible to use our JV agent in combination with other collectors or something like that. That wasn't possible. In addition to that, there was Zipkin, which did a way better job in this case. And in addition to that, in times of microservices and so on, in times of thousands of different services, it is essential that this component can be scaled up. And it wasn't possible with this approach, so we had a really bad scalability, and there was Prometheus and again Zipkin, which did a way better job in this case. And yeah, a rich client is not up to date anymore. It's a very oldish concept. It's not performant and it's inflexible. The reason why we had a rich client was simply because back then the browsers didn't were that mighty in order to build all those tools which you need in order to visualize this data. So what's the reason why all those tools are becoming so successful? It's because of open standards. So there are different open standards. So yesterday there was already a presentation about OpenCensus, OpenTelemetry, and so on. So there's first OpenMetrics, which is a standard mainly used by Prometheus or Micrometer in order to exchange a metrics. So it's quite well known. And in addition to that, there was OpenTracing. OpenTracing is also an approach to have a standardized format on how to exchange traces and spans specifically. And there is a new one, OpenCensus, which was pushed by Google, which somehow is a standard for metrics and for traces. So they both support standards for both of them. And since this really looks a bit weird because you want to have a standard and there are 3 different icons, there's now a new a new community which is called OpenTelemetry. So the idea is to somehow join the forces and to somehow find one solution for this problem, because this is a real problem which has to be addressed, so that you have this interoperability between different monitoring tools. So with those standards, there can be for sure a team which is using Jaeger. There is another team which may be using inspected or old inspected and influx data, and there is another microservice team which is using Prometheus and Zipkin, for instance. And with these standards, it is possible that we have a view about the whole application and see all transactions between the different microservices, and this is really great. Yeah, this is really an advantage of this new open source projects. So with these standards, different teams and tools can operate together. This is just awesome, and this is really fitting with this new microservice DevOps idea. So this sounds like a paradise setting, isn't it? But hold. What about the increasing maintenance effort of monitoring code? So don't know whether you have already used some tracing frameworks, such as the Zipkin SDK or something like that. You usually have to define a tag context, and then you have to put some tags, and then you have to create a tag value. And if your tag value is maybe conditional, you have to have an if case and define, okay, in this case, I want to use this value and that, and then there is a scope. And if you start a scope, then there comes your actual application logic. So this is a huge effort. Of course, this is a very bad example, so there are also frameworks where you can just annotate your method, I know this, but nevertheless, you have maintenance effort. So either if you are using a very cool framework, you have maintenance effort in your source code. And this is, in my opinion, the most important thing. What about if you have an application which is a black box, so where you do not have the chance to change your code, where you do not have the chance to update the source, maybe it's also a legacy application where you do not have this cool Spring frameworks and so on. So, and even if you have a microservice landscape, there is often one service, one old component which is somehow involved in the process of transactions. So some old, don't know, service which is which is sending some data back and so on. And in this case, it's quite hard to do this with these new approaches. So there is no Zipkin agent where you can simply plug in and then it works. And what about the typical APM features? So what about something like that? So if you are using commercial tools, who of you did ever use AppDynamics, Standard Trace, something like that? So you probably might know this service map, which is really great, because I think there are many developers which do not really know how the dependencies between the different services are, because this is really complex. You cannot solve this by hand, so this is not possible. So you have to have such a tool which somehow helps you to do this. And by now there is nothing really sufficient on the open source market. Of course, there might be this Jaeger UI map, but it's not. There is not too much data, and it's also not that yet dynamically adaptable. So, so what about anomaly detection? Yeah, so it would be also interesting to not just have metrics, but do something with these metrics with intelligent methods, with intelligent approaches, such as do baselining and so on. And what about business transactions? So in today's APM context, is very important to also have this business view. So just tagging certain requests that they somehow belong to the same business transaction. So a business transaction would be, for example, a checkout or something like that. And so that you have some grouping based on requests, which would be also very interesting, so that you can also aggregate different metrics and see, okay, there is the average response time of a certain business transaction is very bad. So that's why, because there are still some missing things, we said, okay, we want to fill this gap by introducing inspected ocelot, which is our next project. So it is not based on the old source code of our old inspector. It is written completely new, and it is only the agent, because we thought there is still missing this agent which is capable of doing those things. And there is so many different great collectors on the market which we can simply use. So we do not have to do this by our own. We can simply use it. And this is maybe also the cool idea of the open source monitoring community, just to use existing ones and not to build something for your own. So at least this is my point of view. The basic idea is just to simplify and automate data collection. We can do this by enable distributed tracing for sure. We do this by context-sensitive metrics, by supporting them. In addition to that, supporting some dependency discovery, as you have seen before, such a graph, and of course supporting interoperability. So not to force the customer to only use those tools, so that he's just free to use anything which he wants. And for sure, dynamic instrumentation, so this was also a feature which you already had in the old tool, is a very important thing, because if you once have deployed your application, it's very useful to just change your instrumentation, maybe based on a condition. So if something happens in your source code, you want to increase the sampling rate of the tracing. That would be awesome if you could do something like that. And for sure, runtime attachment would be also very nice. So just saying, okay, let's attach it during runtime. So there's already running some JVM process. So let's just switch on our monitoring. So with this tool, we hope to solve the problem of black boxes and can open this black box. And for sure, do not that we do not have the effort of writing monitoring code, because we have inspected ocelot. So coming to distributed tracing, since we are using OpenCensus as library, which I've presented before, we are capable of exposing our metrics to several different tools. So it is possible by using different trace properties to propagate the trace context to the next service by using headers. So the basic approach is just to use headers. So there's the trace ID, which is important. There's the span ID, which is important. And for sure, you have a start and stop time, which is also relevant in order to compute the response time. And in addition to that, you can just you can just add some additional attributes in order to give some context with it. So it could be a method name or something like that. And for sure, there's a span kind, which is also some basis. And for sure, in order to propagate a span ID, just simply set those different headers. So in order to support this, you have to maybe you can just write an interceptor for your HTTP client, which just sets these headers. So context-sensitive metrics is just adding some additional context, which can be also business-aware context. So you could also add to your metric the current value of your web shop. So the current in your how is it called, in your card? So the current value in your card. So when it comes to dependency discovery, something like that would be very helpful. So see the different services, and not only see the dependencies, but also see quantitative dependencies, such as the number of requests, the number of errors, the response time between the different services. So this is very important when you want to explore. So when you want to see on one view, okay, where it might be a problem, in which service might be a problem. In addition to that, interoperability is possible since we are simply using OpenCensus. And with OpenCensus, you can really use several arbitrary exporters and send the data to Zipkin, to Haystack for sure. So this is a project of Expedia. And also Jaeger is possible. And for sure, Prometheus is also, for metrics, the way to go, I would say. And dynamic instrumentation is also possible. So we do the instrumentation completely asynchronous. This means, and there is an additional thread which is just doing the instrumentation stuff, so we just retransform the bytecode of the application. So the overhead is also configurable. So it is clear if you do something like that, there is overhead. So you will always have overhead. This is clear, but you can configure it. So the instrumentation can also be dynamically changed. So you can just change the configuration file, and then it will be applied soon. So how you can do this? I just brought a snippet of the configuration. Just one question for you guys in the back. Can you see this, or is this too small? No, it's not possible, okay? Okay, I'm so sorry. So maybe I can manage to zoom? No, I can't. Okay, just try it again. No, it isn't possible. Okay, but nevertheless, I just explained it to you. So I think that should be also sufficient. So you can define an inter-batch delay, which says, okay, which times should be between such a batch. So the instrumentation will be done in batches. So you can just define the number of classes which will be transformed per batch, and also the inter-batch delay. So with those two variables, you can simply define the overhead. Because if you just increase the inter-batch delay, there will be less overhead for sure. So that's basically the idea of configuring the overhead. And last but not least, runtime attachment. So you probably might know this construct. So just using this Java agent API, so you just reference your jar, and then in addition to that, you just reference your main jar. So that's basically how you can just start our agent with your Java program. But there is an additional possibility. You can just use the script. So this is working. So you can just type this in and reference your JVM process ID, and then it will work out of the box. And then there will be an additional port exposed on the 8888. And there you will find your Prometheus metrics, which can then be scraped. So that's the basic idea. So you can just try it out afterwards. So this should work. So in addition to that, so by now we only had to focus on the Java application itself, but we want to have end-to-end monitoring for sure. So we also want to see what the client is experiencing, and for that, end-user monitoring is very essential. So let's imagine we have a typical setup, a typical monitoring setup. We have a web server, and we have inspected Ocelot as an agent, which is sending data to some monitoring services, which somehow works, but you do not have the observability concerning the data which is on the client. So we have a client side, so this can be some web page or something like that. And on the client, we are using Boomerang, which is now a bit old JavaScript agent, but it is very mighty. So there are a lot of different plugins which provide you different metrics. And since we are using this, but this is too old to know the new concepts of OpenCensus, OpenMetrics, and so on, we just introduced a new EOM server, and he simply just accepts the beacons which are sent from this JavaScript agent and transforms it to Prometheus. So this is basically the idea how we can then correlate the data in our monitoring services. So with this approach, we can have this end-to-end view. By now, it is only working for metrics, but we are currently working on also supporting tracing on this side. So that's the basic idea. So the configuration is the most important and most exciting part, I would say. So there's a default configuration for sure. So if you're downloading our agent, it is possible to just start it, and it should provide some basic metrics, which might be already some interesting. And there is a file-based version and also server-based version. So we also introduced a configuration server, which just provides the configuration for all the agents. And for sure, as already said, there's dynamic configuration. So all of the configuration properties are dynamically set. So this is very cool. So everything can be changed hot. And there are three key concepts in the configuration. So there are scopes which define basically the scope of the instrumentation, which means, okay, a scope could be all inherited methods of a certain class or all inherited classes of a superclass. So this would be defined as scope in our Java world. And in addition to that, there are rules, and rules somehow combine scopes and actions. So the rule is somehow responsible that we measure a metric or that we measure a trace. And actions are really just actions, so Java actions. So you can really write Java code in our configuration, which then returns a value, and this value will be then used in the rule and processed. So since I've already explained that we have a configuration server, just a brief overview about the current state. So we have, for example, we have two different services which are monitored by our agent. It would be very difficult to deploy the same configuration for the different agents, or even we would have different configurations for those two agents, since that's why we have an additional component which is called configuration server. And with this configuration server, you are capable of configuring the mapping of the different configurations and just deploy it to the several agents. And for sure, since you also want to do this not only based on API, there's also a configuration UI which does support this process. Here are also some screenshots of the configuration server UI. So everything is file-based, so you just can edit these YAML files, and then you can just define an agent mapping. So you can just say, okay, an agent which has this certain tags will get this and that configuration. So you can do very complex stuff with this, and also reuse configuration. Maybe you have a base configuration, and then you have some more specific agents. With this agent mapping, you can really specifically define which agent gets which configuration. So first, let me show you how you can configure the instrumentation of metrics. So there are some basic metrics which you get by default, so such as CPU usage and the number of cores, disk space for sure, memory, the number of threads, and the current state of the threads, and for sure garbage collection is also very important in the context of Java development. So you will also get some data concerning the garbage collection. And for sure, class logging is quite interesting for us, since we are also working with these classes when we retransform them. So that's the basic metrics. So now focusing on scopes. Again, I will just describe it to you, to the people in the back, since you are not capable of reading this. In a scope is defined by a name. So in order to reference a scope, it's very important you have a name. And in addition to that, you can define some additional attributes. And the attribute can be interface, class, or method. And inside of such an attribute, you can just simply define a matcher. In this case, it would be Java util list. So we will match on Java util list. And then there's also the matcher mode. Okay, you could also equals. In this case, it's just equaled fully, so there's a fully match, so that's quite clear how this works. And of course, there's an additional annotation matcher, so you can also match on annotations in your Java code. So now focusing on actions. So as I already said, actions are simply Java snippets which will be executed by a rule. And in this case, we have 3 different actions, and for sure, each action is defined by a name so that we can reference this action again. And in addition to that, you can define an input. So like a normal Java method, this action can also just have an input. And in addition to that, you have a Java code. And this Java code will be then executed if the action will be invoked. So in this case, we have a very simple method which is just calling new long system.nano_time. So it will just return the current timestamp of your system. And this elapsed millis method will get the value, maybe this one, yeah, as an input, and will compute the time between the current time and the time which was given. So that's basically how you could calculate the response time, and that's also the way we did it. So this is basically the idea how you calculate the response time. But this is already a default configuration for sure. In addition to that, there's another one, string replace all, so you can also define some helper actions, so to say. So now this is the most important part. So this is the rule, and in the rule you are capable of put the things together. So you can put the scopes and the actions together. So rule again has some action invocations, as I already said. So you can invoke this action when a certain scope is reached. So you first reference your scope, and then you can also reference an action, and you have two different parts. You have entry and exit. An entry will be executed before you are entering your scope, and exit will be executed afterwards. After you're leaving your scope, or just right before you are leaving the scope. That's more precise. And in this case, we also can define a variable name where we just store the input, not the store, where we store the return value of our action. And we can now, so that's basically the idea. And we can just refer to already existing return values of our action. And based on that, we can just simply calculate our method duration. And since we are using the since nanos method. And now we can simply just expose or define this metric as metric/duration and assign it with this value. So that's basically the idea how you can work with this configuration. So it's very mighty because you can do nearly everything. So by now we just have defined there is a metric. Now you have to expose this metric to your, for example, Prometheus exporter or something like that. And you can do this by simply define a metric, specifically define the unit description and so on. So you probably might notice if you have seen the plain Prometheus scrape input. So there is also a description which you can set. And in addition to that, you can define some views. And the views, in addition to have also some aggregation. So you can choose between sum, count, last value, and yeah. So in addition to that, you can also add some tags. So that would be the configuration snippet which you would have to use in order to add some additional business context to your metrics. And with this, the metric will be exposed. Yeah. So okay, we can skip this. So this is about tracing. Now we just heard about metrics, how you can get metrics, but for sure it is also very very important to define how your tracing strategy is, and you can do this also in a rule again. And there is a tracing part. In this tracing part, you can simply set start span to true, which says, okay, if I am in this scope, in this method, or something like that, then I will start tracing. And you can also define a condition. This means you can maybe compute with an action a very complex condition which says if user X is logging in and the weather is rainy, then I want to start the span. So this would be possible. So you could do this. Don't know whether this is meaningful, but you can at least do this. And for sure, you can also set a sample probability. So we heard yesterday that it is possible to just enable sampling, so such that not each trace will be collected, which is also very useful if you have a very huge setup and there are a lot of traces in your system. This really can slow your system down. And for sure, you can also set this conditionally. So you can also use additional input so that you just reference the return value of an action. So this is also possible. So this is a tracing flag and a sampling rate, so I already said this. So for sure, I already mentioned some exporters. So for sure, you have to define which exporters you want to use. So there are several different exporters which are supported by OpenCensus, and some of them, not all of them, we have implemented. As a small reminder, so we are with OpenCensus, we are able to expose the values to different tools, and for each of these tools you need an exporter at least. And you can also define this in your configuration, so it is possible to just reference under exporters metrics Prometheus and just define, okay, it should be enabled, and this is the host and the port, and then it will be exposed under under the defined port. This is also dynamically changeable, so it is also possible to just deactivate and activate the exporters, which is also really nice. There might be some use cases where you will need this. Just small limitations. There are exporters which have where this isn't possible, but for Prometheus it is possible. So, and in general, it is possible, and for most of the exporters, it is possible, but there are some where this is not working. So, and the same is also stated for tracing for sure. So, you also have to configure exporters for your tracing. In this case, you can simply define the kind, which will be also zipkin. And you can just simply enable your exporters. So you could also just activate Zipkin and Jaeger, would be possible. Yes, don't know whether this is a meaningful use case, but it would be at least possible. And for sure, there is also an OpenCensus agent which you can also add. So this agent can be then process the data and maybe forward it again to some other collectors and so on. So that's it so far for now, and I would just jump right into the demo. So in the meantime, while I am preparing here, you can just ask some questions. So if you have some questions, maybe I can also answer them during the demo. So maybe then some things get more clear. Just have to switch my screens. So, okay, maybe it works, maybe not. Let's see. Okay, you can see something, that's quite cool. Okay, so let's continue. I hope everything is working now. Yeah, it works, yes. So I've prepared a demo setup. So we have some demo application which is called Pet Clinic. You might probably know this demo. It's a very simple microservice application, and all of the different services are written in Java. So it's perfect to use in our case to just show you a demo. And in the background, there's currently running a load test which is continuously executing some requests on the system. So it's very simple. You can have a look on the owners and so on. So it's not too interesting for us. But what is more interesting for us, I just wanted to show you one output of one of these agents which are currently running on one of this service, and you just see the output of the Prometheus exporter, which can be then scraped. So in this case, we would have the HTTP out response time of the certain application, and yes, you have some additional tags which somehow define the context of this metric. So let's continue. In addition to that, we have Prometheus running, and yes, you will see that there are arbitrary different metrics which we can have a look on. So there are also some self metrics. So we also are monitoring ourselves in order to get a feeling how how is the overhead, how is our agent performing, and so on. So we will just increase it a bit more. And in addition to that, we for sure are providing some default Grafana dashboards, which we, wrong password. Okay, now it works. So let's have a look on the overview about the different dashboards. We have here, okay, maybe I can just zoom a bit out because otherwise I'm not capable of showing you anything. So there are some basic dashboards such as a system metrics, so we can just have a look on this metric. So all of these metrics are currently sent by our different services. So this ID is just the Docker container ID. That's why it is set like this. So you can just also adapt this. You see the number of CPUs, you see the current CPU utilization, the load average, CPU usage, and so on, and also some disk metrics, which we can also then use to do some alerting on it. So this would be also possible, as you can also simply use just Grafana as alerting tool, although I wouldn't recommend this, but it would be possible. And so this is basically what you can see. You can also filter by the different hosts for sure. In addition to that, we also have some more aggregated dashboards, such as the HTTP overview, which is really interesting because you just now have an overview about all existing HTTP calls and the average response time. So I'm sorry for the design now because if I zoom in this way, it will not be too pretty. But what you can see is here the average response time of certain HTTP calls and also the response time per time interval. And what's also interesting, what might be also interesting is the outcoming requests for sure. And you can see this for all of the different services. In this case, okay, this is also working in a more pretty way. So you have here API gateway, a customer service, web service, and so on. And you will get this for free. So this is already working without any dynamic or any additional effort on changing the configuration. As I already said, there is also self-monitoring, which is also quite interesting. So what we did here, we tried to visualize the instrumentation scope and also, the instrumentation state. So you see the classes loaded by JVM, the instrumented classes, and are there any classes pending for analysis? So is there a batch job which is currently in progress, retransforming the bytecode? And for sure, you see such a progress bar which just visualizes the instrumentation progress. And for sure, again, you will see this for all of the different services. What we recently added is also the number of errors, and warnings and other things in the log file of our agent. So you will also see here, okay, there might be an error in our agent, and then you can do the deep dive. So that's another feature which we have recently added in order to have a feeling how healthy is our agent. So, and if you're concerned about the concept that you can do such a mighty stuff about the configuration, if you do something wrong, so if there is a compiler error in your action, so the agent will then just disable this rule, so it cannot hurt your or cannot harm your main application. So, and the most brief thing I would say is the service graph for sure. So what we are supporting is such a service graph, which is also fancy animated for sure. So there is also a correlation between the number of different bullets here and the requests, but it's not exactly the same for sure. So what you can see here is simply, okay, there's some user, or in this case this would be our load test, which is doing some requests against our system. There's first the API gateway, and then there are requests to the visit service, and there is a database for sure, and there's a discovery service which isn't monitored maybe, but we also see there is traffic in this direction, so we can also visualize it. And the most important thing on this visualization is this is only done by using metrics. So usually the tools which are supporting this do this based on tracing. And even if you have sample traces, this picture might not be as representative as you want to have it. But if you do this on aggregated metrics, it is as precise as it can be. And it is also you do not have the overhead than using tracing for doing this stuff. And this is somehow part of our project, but this can also be used with other tools. So if you are interested in the service graph, this is also open source, and you can simply use it, and you just have to provide the data in the proper format such that this panel can be used. So this is just a Grafana panel which we just added, and you can just also find it on GitHub. Last but not least, I want to show you a dashboard of the end user monitoring. Therefore, I just have to prepare something, which hopefully then works. Somehow looks good. Now let's see what happens. So there is this EOM summary dashboard, which I will show it to you now. And this somehow summarizes all the metrics which we are currently sending from our JavaScript client to our collector. And since our load test does not execute JavaScript, I just have to do some requests on my own. So I just will click on the application, register something. Now let's see, did it work? Yes, there were some requests. And what you see here now, okay, there was a request from Germany, and there were some requests on some different pages. You can also now filter based on the URL. I just have to refresh maybe. This should work. Sometimes it is a bit buggy. And you can also filter for sure by country. So let me quickly refresh. Now it works. Yeah. So you see here, for example, an average speed index of all clients which are currently connected. So the speed index is basically, does anyone of you know the speed index on client side, JavaScript side? So it's somehow an algorithmic idea to identify whether web page is fast, and they use the rendering of the browser in order to compute this number. For sure, the basic navigation timings are quite interesting, such as the load time, the end of page ready time, and for sure there's also visual ready time, which is a more abstract metric which somehow wants to express until when the web page is really ready to use. So you probably might notice the web page doesn't have loaded in completely, but you can already use some kind of icons and click on it. And this is also a very interesting metric. So what I want to show you now, I hope this works. I just will say I will just do, yes, I will do a request from Russia. So I just have to connect. And now I just have to do some requests. Maybe one interested into this and that. And let's see, there's someone which is currently using our application from Russia. So now you can also filter. Again, I have to refresh, I'm sorry for that. But now you can filter based on the country code. So this is quite cool feature. In addition to that, you can also define some arbitrary country codes, not really country codes, but additional text which we want to add. So it could also be that you want to distinguish between different departments in your company, and then you just use this based on IP. So you can just define some IP ranges and say, okay, this IP range should be mapped to department A, and this IP range should be mapped to department B, and then you can see, oh, department B is always doing some really weird stuff with our application, and yes, this can be visible here. So the last thing which I want to show to you is changing the instrumentation. And so let's have a look on the traces, which I've never. Okay, this I forgot. So let's have a look on the traces, and there's this request which gets the details of the owner. And I now want to know how is the name of this owner. So how is the name of the owner 8? I just want to know this. So what can I do now? I just log into our configuration UI with hopefully the right password. Hey. So in there you see the overview about the current configuration, and we will simply add an additional configuration which does something fancy. So we just say, okay, there's a new configuration file. I would say we just call it OSMC. Fancy stuff. Fancy stuff. So, okay, I've added it here. Yeah, no, it doesn't matter. So now I have to just copy it from my clean desktop. Where is it? 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 Should have been prepared better. Where is it? Let's see. Just too many files. Chaos, just chaos. Okay, that's embarrassing. Also demo. Nice. Okay, I found it. So since we have only a few minutes left, I have to hurry a bit. So I will simply add this configuration, so I already have prepared it. Just for you to understand, there's a scope defined which exactly references a certain method which says get owner details. And in the action, I will use the return value of this method as input and return then _return value.get first name. So my assumption would be now this action would return the first name of this owner. And in the rule, we just put the things together and say, okay, there's an owner name, and we just add the owner name as an additional attribute to our trace. So this would be the idea. So I will just save it now. And now it should be, just let me quickly show it to you. So now my assumption would be, okay, there's instrumentation progress because we now have updated our instrumentation. And now we can just step back to our Jaeger UI and find out whether our changes worked. So let me go back to the search. So there's still coming some old traces since it is buffering a bit, but maybe we will get some traces which might be interesting. Sometimes you have to wait a bit until we see the new traces. So okay, there's still only 9 spans. 10 spans. Okay, we have one additional one, which sounds already promising. And now we see there is an additional span, which is called get owner details. Okay, great. So if we have a look on this, we say, oh, it was Betty. It was Betty. It was Betty's, which was requested. So that would be the use case which we can support, that you can just add arbitrary tags. And this example is just a very easy one for sure. Yes. We can just also start questioning. It's okay for me.
I'm wondering, you have the UI for your YAML. Do you have to use the UI, or is it possible to use config management tool like Puppet? Or
Yeah, for sure. You can also use some arbitrary tools, since there are two different possibilities. You can either use file-based configuration or using our server, but also our server is capable of just doing it via API requests. So maybe you can use the configuration server and do some automated request against the configuration server. But it should be also possible to just provision the configuration with Puppet on your different hosts. So this is possible.
All right, thanks.
So maybe this was a good starting point to start the questioning. So if there are any other questions, I'm really happy. And also if there are just comments or objections, I'm also very happy.
You are only focused on Java, or also possible to have seen some SQL information, or
yes. So
Python or PHP?
Yes, so SQL is, so for sure we want to support that it is possible to have insight on the SQL query, but we do not monitor the database itself in a specific manner. So there might be some additional exporters which can be used, and our main focus is on Java, since our customers just now only are interested in a Java context also, yeah. And also we have the experience in doing it in Java, since we have this history, yeah. So, but for sure you are able to communicate with other technologies, but we do not support the instrumentation for them.
Thank you.
Hi. I've seen the roadmap slide, I think. That
yeah.
And then I saw Kubernetes on there.
Yeah, I forgot because of the demo. Yes, so we want to also support Kubernetes. What would be a great idea would be to support our agent as a daemon set, so that you can simply deploy it to all existing hosts, and that there is a automated detection of JVM processes, which will be then automatically attached. So this attachment already is working, so you just have to add this additional functionality that it works also in the Kubernetes world. But we have this on the roadmap, and this is also a part where we want to invest.
Okay, thank you. Another question is, like, everything that you have showed us today is production ready, customers are already using it?
Yes, there's one customer which is currently using it, so yeah. So it is production ready for sure, yeah. Yeah.
Thank you.
For sure, it is open source, and there might be also some missing features or something like that, but it really depends on your needs, I would say.
Can you show us the roadmap?
Yes, sure. Just one. Just one slide. Just one. No internet connection, but just where is it? So a small fast recap. So what we also want to do is an anomaly detection. So this is currently in progress. Support Kubernetes, as already told. And since there is this change of OpenCensus towards OpenTelemetry, we want to also support OpenTelemetry for sure. So there is this compatibility. So they are compatible, yeah. And yes, that's why it won't be too hard to do this. And also, as already told, we also want to support tracing for the end user monitoring part.
Okay. Thank you very much.